Hi, my name is Tim Fairfield from Keysight Technologies. I am an AE in Toronto, Canada. I'm going to talk about using the um, Bitify HDMI receiver test app, and in the context of programming it remotely to call the functions within. So we'll have a little quick overview of setting things up and programming with Python. And the key thing in here is how to use the kind of like use an offline bit error rate reader. Normally in an HDMI receiver test, you're actually the compliance requires that you look at the screen and can do a manual yes no by staring at the screen. But if you have the ability in your device to have a offline reader, you can actually use this code to stop in the right place, essentially, to use the data from that bit error information that you're supplying from your register set and make the decision and feed that right into the software directly. So it can be completely automated. So that's what we're going to go over. So first of all, I'm going to do everything simulated. So we're going to talk through that. So I'm going to pull this up on the screen first. When I run the station configurator, I'm running the N5991 station configurator. So that's the version I'm using. There is an older version, N5990. That one's being replaced by this. It's just a newer version. This does up to HDMI 2 and 2.1, I believe, is what they're heading towards. And I'm going to be focusing on jitter tolerance tests. So anyway, so let's get this set up. I'm going to choose most of the defaults here. And for simulation, I'm going to keep these all in offline. Now, if I wanted to make them online, I can feed an IP address in here for each of the devices. So I need a scope for the calibration portion. There's the scope application that resides on the scope, and I can turn these on. And if I check these, right now I'm not connected to any equipment, but I have some AWGs and I have a sync module as well. So if I'm actually using real hardware, I need to put the correct addresses, click check connections, and if everything's good, we can proceed. If not, you have to debug basically the connection because this top level software handles all the back-end communication. So I'm going to click finish for that purpose. The next thing is I'm going to launch the actual Valiframe. This is the framework for all of our compliance, receiver compliance applications, and this is the HDMI version. So when we launch this, you can go new, and I'm going to show you, you need to set up, I've got a sync option set up. You can have sync or cable. There's compliance mode or expert mode. I choose expert mode so I can go in and tweak a few of the values if I want. If you want to be fully compliant, that it tests right to compliance, then you use the compliance mode. The expert mode allows you to tweak some things. The other thing here, so we can select the video modes. I'm going to select a couple of video modes. I've got them some default 4096 and 24 hertz refresh. I've got that set. You can set all these if you want. Select all CEA modes. There's also FRL if you're doing that. I'm focusing on just jitter measurements and this just how to get that and how to talk to it with Python. So I'm not going to spend a lot of time selecting all these. And choose offline BER reader. There's the option here for an HDMI controller where we would pull some of that data off of. I'm not going to do that. And once you configure the product, wait a few seconds and this whole list gets populated. When you look at that, you see there are two main sections. We've got the calibration, and then we have the actual sync tests. So in order to do the testing, the AWGs have to be calibrated. So this is a process that it goes through to run this. And when you connect things up for the calibration, it'll tell you physically how to connect things. This is using a text fixture. In some cases, people don't need text fixturing, but most cases you do. This would have HDMI connectors on it, and then they'd be connectorized to SMA connector so that it can be connected to the instrumentation. And then the calibration, the AWG, there's 4 channels being used. Depending on the test and the configuration, they get passed through and sent off to the scope. This setup is dependent on how many probes you are using and the probe type. There are some cases where you would have 4 probes, but based on your presets that we saw in the last view, these will change, but essentially the calibration goes through. You need all the calibration done, obviously, to have a valid run, and I've already done that. even in simulation mode, it has to go through this calibration process. It's kind of a virtual calibration, so you just have to let that run. Right now, it takes about an hour to run. I think the developers need to just remove the timeouts and things, but not a big deal. Just once you run it through once, you're done. That's all set up and ready to go. And when you then we go to run an actual test. So once you've calibrated and everything's good, the check marks will show up. The next thing I'm going to be looking and focusing on this particular test, ID 87. So I'm going to click on this guy, and in there I can see some of the things I can adjust. Now in expert mode, I can go in and change some of these margins. I can change the step sizes, things like that. I could go in and modify that. I can also go back and reset. If I right click, I think yeah, set properties to default. So I can go in and change those if I like. The next thing is let's run it and see what happens. So we'll run this, and while we're waiting, it pops up that this is what you'd normally experience running the app by itself. Not through automation, but this automates a lot of that, but it's not from a top-level automation. It'll pop up a screen, it'll tell you what to connect, and connect your controller and so forth. Now, this is the results screen, and each of the results screens will have different information. This is also your status box down here. Now we're in the stage of downloading segments. Now, like I said before, because we're in a simulation mode, so it's not, skipping over the timeouts and things like that. So it'll take a little bit of time. Right now in software development mode, I've kind of asked for that feature so it would go a little faster, but you're looking about 5 minutes while it's downloading segments. So let's just wait for that to complete. We'll sit here and wait for that to complete, and then we'll move forward. So programmatically, I guess, while we're waiting for this to happen, because it takes 5 minutes to run, we can come in and take a look at some of the back end stuff that we need to look at. So for instance, where is Valiframe stored? Where is this stored? So we're under this PC, Windows, program files, x86, Valiframe K1, that's the N5991 version. If you've installed it, you may only have one folder back here. And HDMI PHY, test automation, and in here we have the structured setup for all of this. Now within this, we have the application. A lot of the DLLs are all in here, and this is what we're going to access with our Python program. And so what we need to do, the essential thing to do, is we need to find, that these tests, which tests have we selected during our configuration, and what tests are available during the configuration, so we can call them from our program. Okay, so we're going to wait for that to run, but let's take a quick look. There's a few things when you're programming in Python with the .NET application. You have a couple of choices of which environment or which interpreter you're going to use. I've got it set for Python 3.8, and the reason I have it for Python 3.8 is that's kind of the latest coding that's been out there. You can use IronPython, but IronPython is only going as far as 2.7, and then a lot of code changes of the baseline code for Python does change a lot. So you can do either, but most requests I have these days are for Python 3.8, so I've set that up. And there you have to make sure that when you're setting up that environment that you correctly install the Python.NET extensions, or the let's go in here in settings, the project interpreter, Python 3.8 for instance. We need to put Python net. Python net needs to be installed. So I'm using PyCharm here, but you want to look up for the packages Python net. The reason you got to use Python net with 3.8, IronPython is set up a little bit differently. It's using the CLR, but when you're using other versions of this, the problem is IronPython knows that, I think way back historically there's been a problem. Somebody named a different package the same thing. CLR, and it caused a name clash, which caused a lot of problems. So if you get it can't find module when on CLR can't find add reference, that means that you run into that situation. So you've got to be really careful using .NET extensions. So Python 3.8, use Python Net. You don't need all these other packages. I just shoved them in for different reasons, but Python Net is what you require. That will fix those resolutions. And then from CLR import system. So IronPython is just set up a little differently when we're doing that. Just wanted to talk about that because it was a real pain for me to understand what's going on. And once you do some research on the web, a lot of people run into this issue. So we're essentially calling a .NET DLL those functions from within Python to do these this programming. So we're almost at the point where we're going to get our pop-up. So that was just an aside. Let's move into this. We're waiting. We should see our dialogues showing up soon. All right, here we go. Setting jitter frequency. So this is the pop-up. Would you like to check the jitter on the scope? If you want to, you can move those. You want to run it on the scope, and after checking, connect the DUT. So we could go directly to the scope and just make sure that everything in the jitter is set up correctly. I'm not going to do that. I'm going to go continue. Now, this is the actual test. So normally with the HDMI receiver test, you're going to be looking at a screen, and it's either going to be pixely and it looks like garbage, or it's going to be look great. So I'm going to keep saying no errors, and it's going to step through. And T-bits is basically a skew step that's going on here. Now, once I'm done and run through all this range and everything passes, we're going to see a pass here. So I could keep doing that. I'm not going to do that because then I don't want to download the next sequence. But the idea is if we were to say no errors all the way through, it would go pass, and then it would continue on to the next test. I'm going to say there's an error. Okay, and once I do it, as soon as I do that, it's going to exit out, because once you've hit a ceiling with jitter tolerance, that's it. The problem is we're not getting this from a BER reader, and that's what we're going to do is make this automated so that we're reading a register value somewhere. So I'm going to say error, and it's going to say fail. Now it's going to download segments and move on to the next test. So it told me how far it got, what did it fail at, and that's as far as it got, so you'll have an idea in your report. I'm going to abort this now. Okay, so procedure aborted by user, because we want to kind of move along here in the demo. That's where we're at. So I'm going to close that. We'll just wait for this to happen. Well, it's probably, yeah, we're just going to kill the process. All right, next. Let's get this up on the screen. Okay. Let's talk about this Python app. So I'm running in PyCharm. I'm going to run this test. Now, here's the thing. We need to point at the directory, which I showed you, which is the test automation Valiframe directory. I'm going to pull that over so we can look at that. We're going to point at the entire directory so we can find all the files it needs. Let's just pull this over here. The next thing is we can automate and skip over things. So set false to let user choose application. We don't need to do that. That's like selecting PCI versus HDMI. We're not doing that. Set true to ask to change application settings. Change procedure. Allow them to change any procedure steps or not in the program. Most of the time you're going to put false for this. You don't want to stop. You just want to automate and go through. But for debugging, you probably do want to have the ability to stop here and there. Show configure.dialog. Do we want to go there, or we just want to use the previous values? I'm going to leave it pop up so we just see where we are and orient ourselves, but we normally would set that to false once we have our program up and running. Here's the key thing: which procedure IDs to run. I want to run the ID, the test 87. In order to figure out what this number and how it corresponds, there's actually an easy way to do that. We run what's called the ValiframeRemote GUI. Now, did I run that yet? No, I did not. ValiframeRemote GUI, let's double click that. And this helps us out a little bit. This is a kind of a test program. We can go applications HDMI. So I'm going to select the application. We got some things popping up here, which is good. And it's checked that out. Now I want to configure the app. So if I click on there, this pops up like we saw before when we were doing manually, and we say OK. This will start checking through a number of things. And now this is where we figure out what the tests are. We could run our calibrations from here, and those have those codes here. What I'm looking for is ID 87. Here we go. ID 87 doing this specific test for 4096K. We're going to go there. We can click that jitter only clock. Now we can click that and that pops it up, and there's that dialog box we saw that we can change the configuration. Plus we get this test ID, the internal number that we can call, which I've put right here. So this number matches that number. I can go through this list and everything I configured will show up here. They actually got this list. There's another way to get this list. If I go down all the way to the bottom, select procedure, added to the list. So if I uncomment this and I run that, it's going to give me a list of all those procedures that are available to me after my configuration. So I can leave that. I'm going to leave it like this. Why not? And then we'll have that pop up. So I'm going to give this a run now, and let's do that. Let's give this a run. Let's make sure I've got this configured right. Edit. I'm running Python 3.8, okay. And we're gonna give it a run and see what happens. This is our log window down here, what's happening, and I can have more or less data being logged. Here we go, it popped up the window like we saw before, good. Now I can turn that off. That's, I showed you up top where we can turn that off. Please select an ID. Okay, so this is this code, the select procedure Valiframe. So this is everything that's available to me in that configuration. Okay, so I am trying to do test ID 7. Good, it's here, and we already selected it up top. If I wanted to change that on the fly here, I could do that. Normally this is commented out. I'm not going to have that. So select on ID. I'm going to go, well, I'm going to have to type something now because it asked me 104. Okay, we're going to select an ID. Now, it also asks me, do I want to change anything in the procedure? So again, this dialog that's in the DLL is now coming here to me and asking me, do I want to make any changes? I don't want to change a procedure property, okay? But I could if I wanted to, and I can skip over this. I can just say no, automatically say no. Now, connect all the lanes, connect all this for further instructions. So this is the connection dialog. Again, I can suppress this up at the top. I can say suppress the messages, ask user to change properties. We could have said false here. Ask user to change procedure settings. Set true to always show the configured dialog. Okay, this is set to true right now. If I don't want this to show, I'm going to set it to false. But I'm going to just say continue. Yes, I want to continue, and so forth. So it's going to come up, and now it's downloading segments. So remember, we saw downloading segments before. We're back to downloading segments now, okay? So let's wait for that to happen. My timer says we're at 10:42 a.m. So we will come back at 10:47. Unfortunately, again, the timeouts are there, and we're going to have to live with that for now. So what we should see, oh, well, while we're waiting, let's go in here. So let's step through the code while we're waiting for that to happen because we need some time for that. So Valiframe log to console. So this is this next one. So we are down here. So the main script is down at the bottom, and this we can make available, this framework for you. Valiframe, start Valiframe register event handler. So that allows us to communicate with the DLL. Application name, init application, configure application, select. Now we're at the run procedures. We're at this point in the game. This is the handshake that happens at this point. I'm going to just search for pop-up dialog because let's search upwards there. Pop-up handler, event handler. So the event handler is where dialog pop-up. The way this works is we're talking to a DLL remotely. So it's another process running at the same time. Once the dialog box pops up and asks you, does this pass or fail, like when you're doing the visual check, the dialog is going to come back to the pop-up handler. A dialog box comes up. It now passes control over to us here. And then we need to confirm or deny that the thing is working or not. So this comes back to here, and we're actually entering and pecking at the keyboard. However, right here, we could take this code that's sitting right here. Let's just zoom in a little bit on that. This dialog pop-up handler, we can come in, we can go and select that and remove that, rip out this code. Normally, if I say no, it's going to send back the system Windows form and the dialog result equals no. In the case of using an external bit error reader, we would just put in a function call here, interrogate bit error reader. Take that bit value, is it pass or fail, and make a decision. If it's a pass, just return, keep returning, everything's good. And then when it fails, then send the system Windows Forms dialog result to no. Okay, and when that happens, that will actually kill, it'll end the test. So I'm going to simulate this. We're going to come in here. The one thing you can't do, though, because it is I think it's asynchronous event that's going on, and there's two different processes running. Right now, I can't, if I wanted to debug this, you can't actually stop in here and inspect values that are coming back. That's one thing you can't do. You'd have to use print statements or something. A lot of debuggers can't do this. There are ways to set this up. For this event handling and debugging on that. But I just wanted to give that piece of advice because I was trying to do a breakpoint here and say, oh, I just wanted to know what that dialogue, what options are available to me, and I wasn't able to do it. So not that it can't be done. Right now, I don't know how to do that. So and I know that PyCharm is going to be adding some of that functions into their debugger. I believe Microsoft, if you're doing this under Microsoft Visual Studio Enterprise 19, supposedly that can be done, where you can trigger on that. And there's probably more sophisticated ways to do that. I just don't know how to do it. So anyway, so we're back here waiting. We're almost at the time where we're going to see something happening down here. Let me see if I can zoom that in a bit. I'm going to make that a little bigger so it's a little easier to see. Yeah, so now we can see that. Waiting for that to come up. So we should see a message come up. Oh yes, and at the same time in the background, this had popped up. I just didn't show you that because it was hidden behind my IDE. So I'm going to put that on the side, and we're going to wait for this to complete, which should be any second. And I'm going to click in here because I have to be interacting down here. Let's just put this over here. And what we will do, we'll say yes, 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 we passed, and then put a no, and then that will throw a fail into the result box at whatever level we failed at, and we'll move on to the next test. And that's exactly what we want it to do. So, okay, here we go. So let me scroll down. Do you like to check the jitter on the scope? So that dialog is popping up. And like I said, we can suppress that. We don't need to look at that. Would you like to, after checking, please reconnect? Continue? Yes, we want to continue. Now, here we go. Errors on the screen. So continue. So it's just the way the dialog messaging is. We see no errors on the screen. We're going to continue forward. We're going to continue. It's going to step through 2 T-bit, 3-bit, 0.4 T-bit. We're going to go to 0.5, and then we're going to say 0.6, and then we're going to say, no, it failed. Okay, and this is like if we called our function and the bit error rate came in. So we're going to say no, boom, we get a fail. And it failed at jitter frequency 5. So 6 didn't pass, but 5 did right here. That is reflected here, so we know exactly where it failed. And the failed skew was at 600 millitbits, I guess is what they're called, or 0.6 T-bits. Now it's gone on to the next test. So now it's downloading segments again. So I think you get the idea here. The key thing where you want to key in on and adding your code is right in here. Okay, so that's pretty much it. Now, what I would do in here is I'd comment these guys out. You can do that like so, and then, well, we can even, well, we can comment that out too, and we could go in and then call, you could call a function that you defined, read BER here. Value, return the value whatever, or value equals read BER, whatever. Anyway, we'd have I don't have the function, but something like that. Then make a decision based on that and do either return or say no, and then you're basically, oh, okay. And one other thing I forgot to tell you, where does this stuff get stored? So when you're done, essentially, log info, test results, save to C program data, Bitify, Valiframe. So let's go into there. Program data, Bitify. Where is it staying at? K1. Temp, TMP, results, HDMI, 5 station, IID 7. We go in there. Well, let's open up with Chrome, and there we go. That's where we failed before, and I skipped through this. You didn't see that part on the code, but that's kind of that's our report. So that's where the data gets stored as well. And if you do choose XML, it will be stored as an XML. So that's where we're at. Hope that helps. That kind of is the guide as well. For the resources, bitify.com is where you would get this. Yeah, probably you need a license even to run this demo, but we can help you with that. And that's about it. So thanks for watching.